Hello students, welcome to Deeksha Karnataka YouTube channel. In this video, I'm going to discuss COMEDK 2024 mock test 1 solution of the COMEDK 2024 mock test 1. Okay, the question number 1 to 30. Okay, part 1. So if you haven't downloaded the paper, please join the WhatsApp channel, which is given in the description box. Okay, so in there you will get the paper and the detailed solution. Yeah. So let's start. Question number 1. The density of the mercury here, the density of the mercury is 13,600 kg per meter cube. Its value in CGS system will be the direct question, right? So its value in CGS system will be 13.6 gram per centimeter cube. Okay, so the correct option is A. Next question, question number 2. During a projectile motion, if the maximum height equals the horizontal range, then the angle of projection with the horizontal. Okay, so maximum height equals the horizontal range, right? So what is the formula for maximum height? Formula for maximum height is u square sine square theta divided by 2g, right? And what is the formula for range? Formula for range will be 2u square sine theta cos theta divided by g. Okay, so now solve this. You will get theta equal to tan inverse of 4. So the correct option is D. Okay, yeah. The next question, question number 3. The displacement time graph of two bodies A and B shown in the figure. Okay, so this is the displacement versus time graph, right? So A and B. The ratio of the velocity of A, VA, okay, this is VA, to the velocity of B, VB is, okay, ratio of velocity of A, that is VA, to the B, VB, we need to find, right? So in displacement versus time graph, if we take the slope of this straight line, we will get the velocity, right? Okay, so now what is the slope of A? The slope of A will be tan 30 degree, right? Tan 30 degree is equal to slope of A, so that is velocity of A, right? And then tan 60 degree is slope of B, so which is equal to velocity of B. So now tan 30 degree is 1 by root 3, right? 1 by root 3. So what is the tan 60 degree? Root 3, right? So now the ratio of A, velocity of A to the velocity of B, so that will be 1 divided by root 3 by root 3, which is equal to 1 by 3. So the correct option is C. Okay, yeah. The next one, question number 4. A motorboat covers a given distance in 6 hours moving downstream of a river. Okay, so this is the river. Okay, this is the direction of the downstream. He covers a distance D. Okay, let's say D is the distance covered by the motorboat moving downstream of a river, right? So velocity of the downstream of a river is U. Okay, velocity of the river is U. Okay, and then here velocity of the motorboat will be V plus U, right? V is the velocity of the motorboat in still water. Okay, here downstream Vd equal to velocity of the motorboat in downstream is V plus U. Okay, it covers the same distance in 10 hours. 10 hours moving upstream. Here river, he moves opposite to the direction of the flow of the river, right? That is the meaning of upstream, right? So now velocity of the motorboat will be V minus U, right? U is the velocity of the flow of water, right? And sorry, U is the velocity of the flow of water. V is velocity of the motorboat in still water, right? Okay. The time it takes to cover the same distance in still water. Okay, we need to find time taken by the motorboat to cover the same distance, that is D, in still water, right? Okay, so we know that velocity V equal to displacement divided by time interval, right? Velocity is equal to displacement divided by time interval. Okay, so now here velocity of the motorboat in downstream Vd is equal to d, right? So this is v plus u equal to d divided by 6 hours, right? So then in upstream, v minus u equal to d divided by 10. Okay, so now add these two equations. Okay, you will get 2v is equal to here d by 6, d divided by 6 plus d divided by 10. Okay, so now 2v is equal to 16d divided by 60. So now 2 8s are 16. So v equal to d divided by 8d divided by 60. So what is v? V is the velocity of the motorboat in still water, right? So we got the expression of velocity of the motorboat in still water, right? So we need to find the time taken by the motorboat to cover the same distance, right? So now time taken by the motorboat to cover the same distance in still water, t equal to displacement divided by time interval, displacement divided by velocity. Velocity is 8d divided by 60. So finally t is equal to 7.5 hours. So the correct option is B. Okay, yeah. Next one, question number 5. A wall is made of equally thick layers A and B of different materials. Okay, thermal conductivity of A is twice that of B. Thermal conductivity of A is twice that of B, right? Here the thickness of the two layers are same, right? So D1 is equal to D2 thickness, right? In the steady state, the temperature difference across the wall is 36 degrees Celsius. Here temperature at one end of the wall, that is A, okay, one end of the wall is A, other end of the wall is B. So temperature at the end of the wall A is TA or theta A. Okay, temperature at the other end of wall, that is wall B, is theta B. So theta A minus theta B is equal to 36 degrees Celsius. Okay, 36 degrees Celsius. 36 degrees Celsius. The temperature difference across the layer A is. Okay, we need to find the temperature difference across the layer, that is theta A minus theta, right? How? See here, this is the wall, okay? This is the common temperature theta. So now theta A and theta B. Theta A minus theta B is 36 degrees Celsius. We need to find temperature difference across the wall, that is theta A minus theta, okay? So we know that heat current H equal to K into A into final temperature minus initial temperature divided by, initial temperature minus final temperature, okay? Initial temperature minus final temperature divided by D, okay? A is the area of this wall, right? Area of the wall is same, right? Thickness is also same, isn't it? So now HA, heat current of A, is equal to heat current of B, right? So from this I can write Ka into theta A minus theta is equal to Kb into theta minus theta B, right? Ka is 2 times Kb, right? So 2 times Kb into theta A minus theta B is equal to Kb into theta minus theta B, right? So now Kb will get cancelled, okay? So now add theta A minus theta to both sides, okay? So now 2 theta A minus, this is theta, okay? It is just theta, not theta B. Theta A minus theta, okay, plus theta A minus theta equal to theta minus theta B plus theta A minus theta. Okay, so here theta and theta will get cancelled, right? Again here theta and theta will get cancelled, isn't it? So now here, sorry, this is 2 theta, right? Sorry, here this is minus 2 theta. Okay, so theta and theta will not get cancelled here. Okay. Okay, now here 3 theta A minus 3 theta is equal to theta A minus theta B, right? So now theta A minus theta is equal to theta A minus theta B divided by 3. Theta A minus theta B is 36 degrees Celsius. Finally, the difference in temperature across the layer A is equal to 12 degrees Celsius. Okay, 36 by 3 is 12. So the correct option is A. Okay, yeah. Next question, question number 6. A cup of tea cools from 65 degrees Celsius to 62.5 degrees Celsius in 1 minute in a room of 22.5 degrees Celsius. Okay. So, okay, let's read the question fully. Then we can solve. Yeah. How long will the same cup of tea take to cool from 46.5 degrees Celsius to 40.5 degrees Celsius in the same room? Okay, here we have to apply the Newton's law of cooling, right? The Newton's law of cooling, that is rate of change of temperature, is equal to the difference in temperature of the surrounding and its, here this will be T, right? Isn't it? So now K into T average minus T, right? T average minus T. So what is delta T? Here the delta T, right? The delta T is 65.5 degree Celsius minus 62.5 degrees Celsius. 65.5 degrees Celsius minus 62.5 degrees Celsius. This is delta T. So which is equal to 3 degrees Celsius, right? So now what is the average temperature, right? So T average is equal to 65.5 degrees Celsius plus 62.5 degrees Celsius divided by 2. So now T average is equal to, here T average is equal to 64 degrees Celsius, right? 64 degree Celsius. Now delta T is 1 minute, right? Delta T is 1 minute. So now, okay, here we have to find the nearest value in minutes only. Okay, we don't need to convert into second. Now delta T is 3 degrees Celsius. 3 divided by 1, okay, 3 divided by 1 equal to K into 64 minus 22 degrees Celsius. 64 minus 20 is 44. 44 minus 2 is 42. So this will be 42, right? So now K equal to 3 divided by 42, right? 3 divided by 42. So we got the value of K, right? So now again apply Newton's law of cooling. So now 46.5 degrees Celsius minus 40.5 degrees Celsius is 6 degrees Celsius, right? So now 6 divided by delta T, okay, 6 divided by delta T, okay, sorry, this is 22.5 degree, okay, so this will be 41.5, okay, 41.5, sorry, this has to be 41.5, 41.5 is 83 by 2, so 3 by 83 by 2 is 6 by 83, so here this will be 6 divided by 83, okay. So now we need to find delta T. So 6 divided by delta T is equal to K is 6 divided by 83 into, so T average, right? So we need to find T average. Here T average is 46.5, so this will be 47, right? 0.5 plus 0.5 is 1, So then 47, 47 plus 40 is 87. 87 divided by 2 is 43.5, right? 87 divided by 2, okay, 87 divided by 2 is 4, then 3, yeah, 43.5. So average temperature is 43.5, right? 43.5. Here, this will be 43.5 minus 22.5. Okay, so now 6 will get cancelled. Delta T is equal to 83. Okay, 83 divided by 43.5. Okay, 43 minus 20 is 43.5 minus 20 is 23.5. Okay, 23.5 minus 0.5, that is 23, again minus 2, 21. So this will be 21, right? 21. So this will be 21. So now solve this, you will get approximately 4 minutes. So the correct option is D. Okay, yeah. Next question, question number 7. If a gas is heated at constant pressure, then what percentage of total heat supplied is used as external work? The direct question, right? Here we need to find the total heat supplied is used as of external work, right? What percentage of total heat, right? What percentage of total heat supplied is used as of external work? Okay, so now we know that dq is equal to ncp dt, right? Cp is specific heat at constant pressure, and then dw is equal to nr dt, right? dq equal to ncp dt, dw is equal to nr dt. So now dw divided by dq, right? See here, what percentage of total heat supplied is used as an external work, right? That is dw divided by dq, then multiply it into 100. So now dw by dq is equal to, here n will get cancelled, so this is dt, okay? n dt will get cancelled. So now this will be r divided by cp, right? R by cp. Gamma for gas is given, right? Adiabatic constant or ratio of the specific heats, right? So now dw divided by dq is equal to R is cp minus cv divided by cp, right? So now dw divided by dq is equal to 1 minus cv by cp, that is 1 by gamma. Gamma is 4 by 3, so 1 by gamma is 3 by 4. So finally dw divided by dq is equal to this 1 minus 3 by 4 is 1 by 4, that is 25%. Okay, now multiply it into 100, you will get 25%. The correct option is A. Next question, question number 8. According to kinetic theory of gases, molecules of gas behave like perfectly elastic rigid spheres. That's it. So the correct option is B. Next question, question number 9. A book lying on the table, okay, a book lying on the table. What is the angle between the action of the book? Okay, here action of the book is force exerted by the book on the table, right? This way. On the table, okay, action of the book on the table and the reaction of the table on the book, right? Reaction of the table on the book. So what is the reaction of the table on the book? So this way, right? So reaction of the table on the book is in opposite direction, right? So this is the action of the book on the table, okay, so that is mg, reaction is n, so angle between these two is 180 degrees. So correct option is D. Okay, yeah. Next question, question number 10. A block of ice at 10 degrees Celsius, minus 10 degrees Celsius, slowly heated and converted into steam at 100 degrees Celsius. Which of the following curves represent the phenomena qualitatively? Okay, so you start to give heat to a minus 10 degrees Celsius, a block of ice block, right? So now what happens? Here this is the cube, right? ice cube. So now temperature changes from minus 10 degrees Celsius to 0 degrees Celsius, right? 0 degrees Celsius, right? So still it is in ice, right? Cube only. Okay, so first what happens, temperature increases, heat will also be increases, right? Isn't it? So then ice converts into water, right? Ice converts into water at 0 degrees Celsius only, right? At 0 degrees Celsius, ice converts into water. So then again you are supplying heat and temperature is also increasing, right? Till 100 degrees Celsius. Till 100 degrees Celsius, right? So what happens? It will start to boil, right? So you are supplying the heat and temperature is also increasing, right? So at 100 degrees Celsius, water converts into steam, or the water will vaporize, right? So here this is water, okay, still it is in water, then steam at 100 degrees Celsius, right? As you increase the temperature, what happens? It will start to vaporize, right? Like this. So this is heat, sorry, this is temperature. Temperature and heat supplied. Temperature and heat supplied. So this is the graph. So the correct graph is A. Okay. Yeah. Next one. Question number 11. The surface energy of the liquid drop is U is split into 1000 equal droplets. Then its surface energy becomes. So what is surface energy? Surface energy U equal to surface tension into change in surface area. Okay. Change in surface area. We need to find surface energy of the smaller droplet, right? Okay. So what is the surface energy of the 1000 droplet? Not smaller droplet, 1000 smaller droplet. Okay. So here volume of the bigger liquid drop is equal to volume of the 1000 smaller liquid drop, right? So now volume of the bigger liquid drop 4 by 3 pi r cube. Capital R is the radius of the bigger liquid drop. So which is equal to 1000 times volume of the smaller liquid drop, right? So now R equal to R divided by 10, right? So radius of the smaller liquid drop is 1 by 10 times the radius of the bigger liquid drop. So what is the here the surface energy of the 1000 liquid drops, right? So U is equal to, sorry, U dash is equal to surface tension S into surface area. Surface area will be surface area of 1000 drops, right? 1000 into 4 pi small r square. Okay, small r square is r divided by 10 whole cube, sorry, whole square, right? So now U dash is equal to here S into 4 pi r square into 10, right? So what is S into 4 pi r square? S into 4 pi r square is U, right? That is the surface energy of the bigger liquid drop, right? So now U dash is equal to 10 times U. U dash is equal to 10 times U. So from this, here we can conclude that if you divide the bigger liquid drop into smaller liquid drop, what happens? The surface energy decreases or increases? Here the surface energy will be decreases, right? So the correct option is B. Okay, yeah. Next one, question number 12. The maximum speed of the particle executing simple harmonic motion is 10 meter per second. So V max is equal to omega into A. Omega into A is 10 meter per second. Maximum acceleration is 31.4 meter per second square. So A max is equal to, in magnitude, okay, in magnitude A max is equal to omega square into A. Its time period is, we need to find the time period of the simple harmonic motion, right? Okay, so here A equal to V max by omega. From this equation I can write A A is amplitude, omega is angular frequency, right? V max divided by omega. So now substitute here. So A max is equal to omega square into V max by omega. So omega will get cancelled, right? So now omega is 2 pi by t, right? So t is equal to 2 pi into V max divided by A max. So A max is 31.4 meter per second square. I can write it as 10 pi, right? 10 into 3.14 is 31.4 meter per 31.4 acceleration, so meter per second square. So t is equal to 2 pi into V max. Here V max is 10 divided by A max is 10 pi, right? 10 pi. So pi will get cancelled, 10 will get cancelled, t equal to 2 seconds. So the correct option is A. Okay, yeah. Next question, question number 13. A string of linear density 0.2 kg per meter stretched with the force of 500 Newton. Here tension is 500 Newton. Here linear mass density, that is mu, is 0.2 kg per meter. A transverse wave of length 4 meter is stretched up along it. The speed of wave. Okay. So now speed of wave v equal to root of t divided by mu. T is tension in the string, mu is linear mass density. So v equal to root of 500 divided by 0.2. 0.2 is 2 divided by 10, right? 2 by 10. So now v is equal to root of 500 into 10, that is 5000, right? 5000 divided by 2. 5000 by 2 is 2500. So v equal to root of 2500, right? Root of 2500. So now here, what is the root of 2500? 50, right? So v equal to 50 meter per second. That's it. So the correct option is A. Okay, yeah. Next question, question number 14. An artificial satellite is moving in a circular orbit around the Earth with a speed equal to half the magnitude of escape velocity from the Earth. The height of the satellite above the Earth's surface is. Okay, we need to find height of the satellite above the Earth's surface. Here g is 9.8 meter per second. Radius of the Earth is 6400 kilometer, right? So here this is the planet, okay, artificial satellite, okay, moving around this planet. The radius of the orbit is r plus h. So we need to find the value of h, right? Okay. So now here this satellite is moving around the orbit in a circular path, right? So now the centripetal force provided by the gravitational force, right? So now centripetal force of this satellite mv square divided by r plus h is equal to mv square divided by r plus h equal to v is speed of the satellite, okay, is equal to gravitational force acting on gravitational force between the planet and the satellite, that is g mm divided by gmm divided by r plus h whole square. So r plus h will get cancelled, right? So in the question they have given the speed of the satellite is equal to half the magnitude of the escape velocity, right? So what is the escape velocity? Escape velocity is equal to root of 2gm divided by r, right? R is the radius of the radius of the Earth, right? Okay. So now according to the question, orbital velocity or speed of the satellite is equal to half the magnitude of the escape velocity, that is ve divided by 2, right? ve divided by 2. So now here VO is equal to VE, right? So VE will be root of 2gm by R, right? So root of 2gm divided by R whole divided by R, right? Sorry, whole divided by 2, not R. Whole divided by 2. Okay, so now VO is equal to, or VO squared is equal to V square, okay, which is equal to GM divided by 2R, okay, GM divided by 2R. So now here substitute the expression of V squared to this equation, okay. So now GMM divided by 2R is equal to GMM divided by 2R is equal to here GMM divided by R plus H. So GMM will get cancelled. So solve this, you will get H equal to R. R is the radius of the earth, that is 6,400 kilometers. So the correct option is A. Okay. Yeah. Next question, question number 15. A charge Q is distributed over two concentric hollow spheres of radii R and R. Smaller is lesser than capital R, such that the surface densities are equal. The potential at the common center is, okay. So what is the total charge? Total charge is Q. It is distributed over two spherical shell, concentric hollow spheres, right? So that will be Q1 and Q2. Q1 is the charge on the inner hollow sphere and Q2 is the charge on the outer hollow sphere. The density, the surface charge density is same, right? Or equal. That is sigma of Q1 is equal to sigma, okay, sigma of the first hollow sphere, okay, sigma of the first hollow sphere is equal to sigma of the second hollow sphere, right? So sigma 1 is equal to Q1 divided by 4 pi R square, which is equal to Q2 divided by 4 pi R square, okay. So now 4 pi capital R square, this is not small r square, capital R square. Yeah. So 4 pi will get cancelled, right? So now Q2 is equal to Q1 into R square divided by small r square. So now substitute the expression of Q2, the first equation, this equation, right? So now Q equal to Q1, take Q1 as common. So 1 plus capital R square by small r square. So that will be R square plus R square divided by small r square. Okay. So this is Q, right? So this is capital Q, right? So now I can write Q1 is equal to capital Q into small r square divided by R square plus R square, R square plus R square. Okay. Okay. So now we got the expression of Q1, right? So here we need to find the potential at the common center. Okay, let us draw the diagram. Here, this is the two hollow sphere, right? R and R. So we need to find potential at the common center, right? So potential at the common center, here this is Q1 and Q2. Okay, potential at the common center V equal to K Q1, okay, K Q1 divided by small r plus K Q2 divided by small r, right? K Q2 divided by capital R. Okay. So now V is equal to here K into Q1, right? So Q1 plus Q2 is Q1 R square by R square, right? Q2 is Q1 R square by R square, right? So K Q1 by R plus K into Q1 R square by R square whole divided by capital R, right? Okay, so now here R will get cancelled. So now V equal to, take KQ1 as common, okay, KQ1 as common. So here this will be 1 divided by R plus R divided by capital R, right? Okay, so now here V is equal to, sorry, capital R, so small r square. Okay, so this is small r square. So now K into Q1 is here Q1, sorry, capital Q into R square. Okay, Q1 is capital Q into small r square divided by R square plus R square, right? R square plus R square into here, here this will be 1 divided by R plus R divided by R squared. Okay, R divided by small r square, right? R divided by small r square. Okay, so let's see. Q2 we have correct, right? We have Q2 correctly, and then here Q1 is QR square divided by R plus R square, right? So KQ1 divided by R, KQ2 by capital R, right? So Q1 R divided by, sorry, R square by R square, R will get cancelled, so this will be R square. Okay, yeah. So now here solve this, you will get V equal to Q into R plus R divided by K is 1 by 4 pi epsilon naught, so 4 pi epsilon naught R square plus R square. So the correct option is D. Okay, yeah. Next question, question number 16. The plates of parallel plate capacitor have an area of 100 centimeter square. A is 100 centimeter square. Okay, each, okay, 100 centimeter square each, and are separated by 2.5 millimeter. D is 2.5 into 10 to the power minus 3 meter. The capacitor is charged to 200 volt. The energy stored in the capacitor is, okay, so energy stored in the capacitor, U equal to half CV square. Okay, so U equal to half into C is epsilon naught A divided by D into V square. Okay, so now U equal to half into epsilon naught is 8.85 into 10 to the power minus 12 into A is 100 centimeter square, that is 100 into 10 to the power minus 4 into V square is 4 into 10 to the power 4 divided by D is 2.5 into 10 to the power minus 3 meter. Solve this, you will get 7.08 into 10 to the power minus 7 joule. So the correct option is D. Okay, yeah. Next question, question number 17. In a region of space, the electric field is given by E vector equal to 8i cap plus 4j cap plus 3k cap. The electric flux through the surface of area 100 units in xy plane. Okay, we need to find electric flux, right? The surface area of 100 units in xy plane. So here x, y and z, right? So the surface area is along xy plane, right? So the direction of the area vector is along z axis, right? So this is 100 k cap. So now electric flux phi is equal to E vector dot A vector. So now phi equal to E vector is 8 I cap plus 4j cap plus 3k cap dot 100 k cap. So solve this, you will get phi equal to 300 units. So the correct option is B. Okay, yeah. Next question, question number 18. A water molecule has an electric dipole moment 6.4 into 10 to the power minus 30 centimeter. Electric dipole moment P equal to Q into L, so which is equal to 6.4 into 10 to the power minus 30 centimeter. Okay, a water molecule has an electric dipole moment 6.4 into 10 to the power minus 30 coulomb centimeter. Okay, so this will be 10 to the power minus 32. Okay, coulomb centimeter. This is coulomb centimeter. When it is vapor state, the distance in meter between the center of the positive, okay, let's say this is 2ql, okay, 2ql, center of the positive and negative charge of the molecule is, okay, we need to find distance between the center of the positive and negative charge of the molecule. So how many number of electrons and protons are there? So total 10 number of electrons and protons are there in water molecule, right? H2O. Total 10 number of electrons or protons are there. So now P equal to, P is equal to 10E into Q is 10E into 2L. Okay, Q is 10E into 2L. So now P is given, we need to find L. So L equal to P divided by 10 into 2 into E. So E is 1.6 into 10 to the power minus 19 coulomb, and P is given, right? So now solve this. L equal to here 4 into 10 to the power minus 12. 4 into 10 to the power minus 12. Okay. So what is the SI unit? So here this will be 10 to the power minus 32 meter, right? Coulomb meter. 10 to the power minus 32, right? So this will be 10 to the power minus 19, right? 32 minus 10, 22 minus 9, right? Yeah, this will be meter. It will be in meter. So the correct option is C. Okay, yeah. Next one. So this is in meter. This is in meter. Yeah. Next one, question number 19. A force between two identical charges placed at a distance in vacuum is F. Now the slab of dielectric constant is K. Constant K equal to 4 is inserted between these two charges. The thickness of the slab is R by 2. The force between the charges will now becomes. Okay. So here two charges Q and Q. The force between them is F. So this is R. Force between them is F, right? So now we have inserted dielectric slab. Dielectric slab, right? The thickness is R by 2. Dielectric slab. The thickness is R by 2. So what is the force between these two charges? Okay. Let's say, suppose the distance, force between the two charges is same. Okay. Before and after inserting the slab. Okay. So this is dielectric constant K. So now F dash is equal to 1 divided by 4 pi epsilon naught Q square divided by K into R dash square. If the force is same, then distance will differ, right? So Q square divided by K into R dash squared, right? So 1 divided by 4 pi epsilon naught into Q square divided by K into R dash squared, right? So F equal to 1 divided by 4 pi epsilon naught Q square divided by R square when there is no dielectric. F dash is equal to F. I have assumed that. Okay, suppose F dash is equal to F, right? So 1 by 4 pi epsilon naught and 1 by 4 pi epsilon naught will get cancelled, right? So Q square will get cancelled. So 1 by K into R dash square is equal to R square, right? So now R dash is equal to, here R dash is equal to R square equal to K into R dash squared, right? R dash is equal to R divided by K, right? R dash is equal to R by K, or R equal to R divided by root K, okay? R equal to root K times R dash, okay? Root K times R dash. Here what is R dash? R by 2, right? R dash is R by 2, isn't it? So now here the new force F dash is equal to 1 divided by 4 pi epsilon naught into Q square divided by here thickness of the dielectric slab is root K into R by 2, right? Isn't it? Because of the thickness, here the distance will be root K into R by 2, right? Root K into R by 2, then plus R by 2. So R by 2 into root K into R by 2. Okay, so this is the distance. So then this will be whole squared, right? So now solve this, you will get F dash is equal to 4 by 9 F. So the correct option is D. Okay. Question number 20. a hollow metal sphere of radius 5 centimeter is charged such that the potential on its surface is 10 volt. The potential at the center of the sphere. Potential at the center of the sphere is 10 volt only. Okay, because inside the hollow metal sphere, the electric field is 0. If electric field is 0, potential is constant. We know that electric field E equal to minus dV by dr. Electric field is 0. So potential will be constant, right? Differentiation of constant is 0. So potential will be constant. So the potential will be 10 volt only. Okay. Yeah. Next question, question number 21. When no current is passed through the conductor, through a conductor, the free electrons do not move. When no current passes through the conductor, free electron do not move. It will move. Okay. The free electrons are moving. Okay. The motion of the free electrons are random. So option A is wrong. Option B, the average speed of the, okay, and another condition is free electrons do not move when the conductor kept at absolute temperature, that is 0 Kelvin. Okay, then only the free electrons do not move. Okay, the average speed of a free electron over a large period of time is 0. Average speed is not 0. Okay, average speed is not 0. Average velocity is 0. Velocity has direction. Speed does not have any direction, right? Speed is a scalar quantity. So you can directly add the magnitude of the speeds, right? Sorry, velocity, right? So average speed is not 0. Okay, so option B is wrong. Option C, the average velocity of a free electron over a large period of time is 0. Correct. This is correct. Average velocity is 0 because electrons are moving in random direction, right? Isn't it? So here the velocities will cancel out. Okay, average velocity over a large period of time is 0. The average velocity of the velocity of all the free electrons at an instant is non-zero. This one is wrong. At an instant is also 0. Yeah, the correct option is C. Next question, question number 22. A metal wire is subjected to a constant potential difference. Okay, metal wire is subjected to a constant potential difference. When the temperature of the metal wire increases, the drift velocity of the electron in it. Okay, when you increase the temperature, what happens? Kinetic energy of the electron increases. Okay, kinetic energy of the electron increases. Okay, so that is the thermal velocity. Thermal velocity will also be increases. Thermal velocity will also be increases. But the drift velocity will be decreases. Okay, Vd will be decreases. Why it decreases? Because more number of collisions, right? More number of collisions. Okay, because of the more number of collisions, drift velocity will be decreases. Why? Because of the more number of collision. Okay, if the number of collision increases, what happens? The relaxation time will also be increases, right? Isn't it? So the time taken by the electron to move from one end to the other end will also be increases. So drift velocity will be decreases. Kinetic energy of the thermal velocity of the electron increases. That is kinetic energy of the electron increases. So the correct option is B, decreases. Thermal velocity of the electron increases. Yeah. Next question, question number 23. The figure shows a network of currents. The magnitude of the currents shown here, the current will be. Okay, simple question, right? Apply Kirchhoff current law. Okay, so at this point 15 ampere will divide, right? So here 8 ampere, so the remaining will be 7 ampere, right? 7 ampere. So now at this point 7 ampere and 3 ampere will add up. So this will be 10 ampere current in this wire, right? Okay, so this is I dash. So now here the 5 ampere is coming to this junction, right? And 8 ampere coming to this junction. So the total current leave from this junction is 13 ampere. Okay, so now total current coming to this junction will be 23 ampere. Here 23 ampere. And total current leaves from this junction is also 23 ampere. So current I equal to 23 ampere. So the correct option is D. Okay. Yeah. Next question, question number 24. If the resistance of a conductor is 5 ohm at 50 degrees Celsius. Okay. Here let us write the equation, temperature dependent on resistance. Okay. Okay, resistance dependent on temperature, right? Okay. R at 50 degrees Celsius is equal to R naught into 1 plus alpha into delta T. R naught is resistance of the material or conductor at reference temperature. We don't know the reference temperature, right? Reference temperature is something T, okay? Now here, so this is 5 equal to R naught into 1 plus alpha into 50 degrees Celsius. And 7 ohm at 100 degrees Celsius. Again, use this formula. 7 is equal to R naught into 1 plus 100 into alpha. Okay. Then mean temperature coefficient of resistance, that is we need to find the value of alpha, right? So now divide this equation by this equation. 7 divided by 5 is equal to R naught will get cancelled, right? So here 1 plus 100 alpha divided by 1 plus 50 alpha. So now solve this, you will get alpha equal to 0.013 per degree Celsius. So the correct option is A. Okay, yeah. Next question, question number 25. An electric heating element consumes 500 watt when connected to a 100 volt line. If the line voltage becomes 150 volt, the power consumed will be. Okay, we need to find power consumed, right? Okay, we know that power P is equal to V square divided by R, right? So V is the applied voltage, right? Here the electric heating element connected to a 100 volt line, right? Isn't it? So V is the potential, R is the resistance of the heating element, P is the power consumed, right? Okay, so R is constant, right? So P is directly proportional to V square, right? Okay, so now P2 divided by P1 is equal to V2 squared divided by V1 squared. P1 is 500 watt, right? So P2 is equal to 500 into V2 square is 150, V2 is 150, V1 is 100 whole square. So 10 will get cancelled, here 2 and 3, right? So P2 is equal to, solve this, you will get 1125 watt. So the correct option is D. Okay, yeah. Next question, question number 26. 6 lead acid type of secondary cells, each of EMF 2 volt. Okay, each lead acid type of semiconductor cells has EMF 2 volt. So the total EMF E total is equal to 12 volt, right? And internal resistance 0.015 ohm. So here RT, total internal resistance, is 0.015 into 6. Okay, are joined in series to produce a supply to a resistance of 8.5 ohm. So capital R is equal to 8.5 ohm. So what is the total resistance? Total resistance will be 8.5 plus 0.015 into 6. So that will be 8.59 ohm. Okay. What are the current drawn from the supply and its terminal voltage? Okay, so current drawn from the supply, I equal to total voltage, that is 12 divided by 8.59. So solve this, you will get 1.4 volt. Okay, 1.4 volt. So now what is the terminal voltage, right? Terminal voltage across the terminal voltage we need to find across the supply. Okay, so now the terminal voltage V is equal to current into the total resistance. So now terminal voltage is current 1.4 into total resistance, that is 8.59. So solve this, you will get 11.9 volt. Okay, so this is ampere, not volt. Sorry, this is ampere. Okay, so the correct option is A. Yeah. Next question, question number 27, right? The speed of an electron having a de Broglie wavelength of 10 to the power minus 10 meter is. So apply de Broglie wavelength formula, lambda equal to h divided by p. P is momentum of the electron. P is m into v, right? V equal to h divided by m into lambda. Okay, h divided by m into lambda. So now solve this, you will get v is equal to here h is 6.625, okay, sorry, 6.6, right? 6.67 or 6.66 into 10 to the power minus 34, right? Into, sorry, divided by m is mass of the electron, 9.31 into 10 to the power minus 31, right? Sorry, 9.1 into 10 to the power minus 31, 9.1 into 10 to the power minus 31 into lambda, okay, lambda is 10 to the power minus 10. So now solve this, you will get 7.25 into 10 to the power 6 meter per second. So the correct option is A. Okay, yeah, next question, question number 28. A surface irradiated with light of wavelength 480 nanometer gives out electrons with maximum velocity v meter per second. Let us write the photoelectric equation. Energy of the incident light is equal to maximum kinetic energy of the photoelectron, half mv square, plus work function, that is hc by lambda naught. Okay, the cutoff wavelength being 600 nanometer, the same surface would release electrons with maximum velocity 2v meter per second if it's irradiated by the light of wavelength. So here maximum velocity of the electron becomes 2 v meter per second. Okay, so when the light of wavelength irradiated by, right, or irradiated by the light of wavelength, right, we need to find what is the wavelength of the light incident on the photoelectric metal so that its maximum velocity becomes 2v meter per second, right? Okay, so here when the lambda is 480 nanometer, okay, let us write the photoelectric equation. hc by lambda 1 is 480 nanometer. Okay, hc by lambda 1 is equal to half mv square plus hc by lambda naught, first equation. Okay, so now the second wavelength is lambda 2, so hc by lambda 2 is equal to half m into 2v whole square, that is 4v square, so half mv square into 4 plus hc by lambda naught. Okay, so now I can rewrite this equation as here hc divided by 4 lambda 2, okay, minus hc divided by 4 lambda naught is equal to half mv square. So now substitute this equation to the first equation. Okay, half mv square to the first equation. So what happens? hc by lambda 1 minus hc by lambda naught, right, equal to half mv square, right, hc by lambda 2 minus hc by, sorry, this is 4 lambda 2 minus hc by 4 lambda naught. So hc will get cancelled, right? So we need to find lambda 2, right? So 1 by lambda 1 minus, so take 1 by 4 lambda naught to the other side, so this will be 1 by 4 lambda naught, right, minus 1 by lambda naught, right? So this will be 3 divided by 4 lambda naught, which is equal to hc sorry, 1 divided by 4 lambda 2. 1 divided by 4 lambda 2. So now 1 divided by lambda 2 is equal to 4 by lambda 1 minus 3 by lambda naught. So lambda naught is 600 nanometer, okay, cutoff wavelength, 600 nanometer, and then lambda 1 is 480 nanometer, substitute, okay. So we will get 300 nanometer. 300 nanometer. So the correct option is D. Okay. Yeah. Next one. Question number 29. A galvanometer has 30 divisions and a sensitivity 16 microampere per division. Okay. Let us find the current flowing through the galvanometer. Ig is equal to 16 microampere per division into 30 division. Right. So now Ig is equal to 480 microampere. Okay. It can be converted into voltmeter to read 3 volt by connecting. Okay. So we have to convert galvanometer to voltmeter, right? So in that case, we have to connect the resistance or external resistance in series with the galvanometer, right? So now the external resistance R is equal to V divided by Ig minus G. So they didn't give the G value, that is resistance of the galvanometer. So R equal to 3 divided by 480 into 10 to the power 6, right? So now R equal to, solve this, you will get 6 kilo ohm. It is in series. So the correct option is A. Okay. Next question, question number 30. If the resistance of the upper half of the rigid loop is twice that of the lower half, so resistance of the upper half is twice that of resistance of the lower half, the magnitude of the magnetic field at the center is equal to. Okay. So here at this point the current will divide, right? Isn't it? So in upper half resistance is more compared to the lower half, right? So what is the ratio of the resistances? 2:1, right? So 2:1. So therefore the current will divide here. This will be I divided by 3 and 2I by 3. 2I by 3. So now apply right hand thumb rule. Here the direction of current O due to the upper half is into the plane, and the direction of the magnetic field at O due to the upper half is into the plane, and due to the lower half is outward from the plane, right? Take outward from the plane as positive, upward from the into the plane as negative. So now magnetic field due to the circular arc at its center will be B equal to, yeah, B equal to mu naught I divided by 2R, here 2A, radius is A, into theta by 2 pi, right? So due to the upper half, magnetic field Bu is equal to mu naught I is I by 3 divided by 2A into theta is pi, right? Pi divided by 2 pi is 1 by 2. So now B lower is mu naught I, 2I by 3 divided by 2A into 1 by 2. Okay. So now net magnetic field at O is equal to BL minus B plus BU. Okay. So here the magnetic field is into the plane. Okay. Here the magnetic field is outward from the plane. So now solve this, you will get BO, magnetic field at the center will be mu naught. See, into the plane taken as negative, outward from the plane taken as positive. Solve this, you will get mu naught I divided by 12A. So the correct option is C. Okay. Yeah, that's it. Okay. Thank you so much for watching this video. If you love this video, please like and share, and if you want to watch more such videos, please subscribe. Thank you.